Hello, my people. Good morning, good afternoon, good evening. This is Tasien. I'm happy to be here again. Welcome to Matify Analytics. Where are you watching from? I'm saying a morning, afternoon, and evening, but where are you watching from? Is it morning or afternoon or evening? Write in the comment section and let us know where you are watching from and tell us if it's morning or evening or afternoon. Yes, before I start, I want to thank everyone who is watching this video, whether you have subscribed or you have not yet subscribed. Everything that you are doing to support our community, we are thankful for it. Your likes, sharing to your friends, your comments, everything. We are grateful for everything. You mean a lot for us. Thank you for your support. In today's video, I'm going to solve questions, a number of questions from the national examination that was done last year in Rwanda, 2024. It was a national examination for people who were in section. There were many sections in this examination. It was section MCB, MCE, MEG, PCM, MPG, and the MPC. Yeah, so see, it was main options that was supposed to do this exam. So I hope these solutions are going to be useful for many students who are preparing for their examination this year. So if you are preparing your examination, you are at the right place. Or if you know someone who is preparing his exam, let them know that we are solving these questions. In today's video, I'm solving question number 10 to question number 15 if I happen to have time. I hope you are going to enjoy today's presentation. If you like the video, don't forget to click like and share the video to your network. And if you have a question, write the question in the comment section. Or if you have anything to add to our solutions, write it also in the comment section. So without wasting our time, let's start. So we are going to start with question number 10, and the question number 10 was this. In a geometric progression, the sixth term is 80 times the third term, and the sum of the seventh and eighth term is 192. Determine A, the common ratio, and B, the first term, and C, the sum of the fifth to 11th terms. Yeah, so let's see how we can deal with this equation. We have a geometric progression. So all what we have to know is that in a geometric progression, the term, let's say that we need the term number n, Sn, will be equal to r power n minus 1 times S1, where this S1 is the first term. This is the first term. This is the first term, and Sn is the nth term. So we need to keep in our mind this relation. So in any geometric progression, we have this relation. Sn is equal to r power n minus 1 times S1, and where r is the common ratio. So we have been given one assumption. It has been said that the sixth term is equal to 8 times the third term. This is the assumption that we have been given. And the second assumption that we have been given in the question is that the seventh term plus plus eighth term, this is S8, is equal to 192. We have these two assumptions, and A, we are asked to find the common ratio. So let's start from number A. To find this common ratio, we are going to use this first assumption, And from this, I hope that we are going to get the common ratio. So from this first assumption, we can compute S6. S6 is equal to R power 5 times S1. I'm using always this relation because we have a geometric progression. And S3 is equal to R power 2 times S1. Yes, like this. And from this, and if we use the first assumption, this implies that S6 R power 5 times S1 will be equal to 8 times S3. S3 is equal to R power 2 times S1. So from this you can see that we can simplify. This S1 and S1 can be simplified, and then this R squared can be simplified here. Then we remain with R3 here. So then what do we get? What do we get? We will get R power 3 equal to 8. Then from this we get R to be equal to 2. This is the common ratio. Our common ratio is equal to 2. So that was the common ratio. Common ratio is equal to 2. Then B. Question number B was that we have to compute the first term, S1. So given that R is equal to 2, and given this assumption, second assumption, given that S8 plus S7, so let me start by S7. S7 plus S8, S7 plus S8 is equal to 192, and R is equal to 2. So we can compute S7 as R power 6 times S1. I'm always using this relationship up here. This relationship. So S7 is equal to R power 6 times S1, S1 being the first term, then plus S8. S8, this is R power 7 times S1, and this is equal to 192. So from here you can see that S1 times R6 plus R power 7 is equal to 192. Yes, and then you can see that S1 will be equal to 192 over R power 6 times 1 and plus R. Yes. And what is R power 6? R power 6, R is equal to 2. From here we have S1 equal to 192 over R power 6. This is 2 power 6 times 1 plus 2. 2 power 6 is equal to what? This is equal to 192. Then over 2 power 6, this is equal to 64. 64 times 3. 62 times 3 is equal to what? This is equal to 192. So this is equal to 192 over 192 and equal to 1. So we get the first term to be equal to 1. S1 is equal to 1. So this was the first term, and it was B. And C, we were asked to find the sum of the terms from S5 to S11, from the fifth term to the 11th term. In C, we are asked to compute S5 plus S6 plus S7 plus S8 plus S9 and plus S10 and plus S11. So this how to compute this. S5 is equal to R power 4 times S1, right? Yes. And S6 is equal to R power 5 and times S1. And S7 is equal to R power 6 times S1. S8, this is R power 7 times S1 plus R power 8 times S1 plus R power 9 times S1 plus R times 10 times S1. So S1 is equal to 1. S1, we have seen that S1 is equal to 1. So this sum will be equal to R power 4 plus R power 5 plus R power 6 plus R power 7 plus R power 8 plus R power 9 and plus R power 10. Yes, so this is equal to R power 4 and times 1 plus R squared plus R power 3 plus R power 4 plus R power 5 plus R power 6, like this. And then finally, what do we get? We get R is equal to 2. This is 2 power 4 times 1 plus 2 plus 2 power 2 is equal to 4 plus 2 power 3 is equal to 8 plus 2 power 4 is equal to 16 and 2 power 5 is equal to 32 and plus R power 6 this is equal to 64, like this. And what do we get? We get 2 power 4, this is 16. 16 times this sum, this will sum to 127. And the final answer will be equal to this is 3032. I don't remember if the solution is this one, but it must be that one. Yes. So that was it. Question number 10 was that what you have to know, the core of this question is this formula. So keep it in mind. This formula is important for any geometric progression. So thank you. That was question number 10. Now let's move to the next question. Next question is question number 11. It says each student in a class gives each other a shake hand. Sorry, excuse me. If there are 66 handshakes done in general, how many students are in the class? So this question, is it about the permutation or it's about the combination? For those who have not yet watched my videos about permutation and combinations, I saw that many people didn't watch those videos, but those videos are important. Please, I recommend to go and watch those videos. I'm going to pin those two links in the comment section for you to watch if you are interested, of course. But for this question, we have shaking. The action is shaking hands. So if I am John and you are James, we are shaking hands. Hi John and hi James. It doesn't matter by starting saying that John shakes hands with James, or James shake hands with John. It's just one shake hands. There will be no two shake hands. So it's just one shake hands between James and John. Yeah, so since the order here, it doesn't matter, we have combination, because the order here doesn't matter for one action. It's just one action, even if two people are involved in the action, but the order doesn't matter. So then we have combination. So all what we have in this equation is that we know that number of handshakes is 66. We have number of handshakes is 66 handshakes. So this number of handshakes, it will be a combination of number of students. I call it n, then 2, because two people have to shake hands. And I hope you remember this formula when we are computing the combination nr into r. So this is equal to n factorial over n minus r factorial times 2r. Not 2, times the r. I say 2 because I have 2 there. So times the r factorial. This is the general formula for combination calculations. Yeah. So similarly, we will have 66, which will be equal to n factorial, n being the number of students, then over n minus 2 factorial times 2 factorial. Yes, like this. So this will be the same as 66 equal to n factorial is the same as n times n minus 1 and times n minus 2 factorial, and over I'm expanding it so that I will be able to simplify. Then over n minus 2 factorial times 2 factorial, and I can simplify this n minus 2 factorial and n minus 2 factorial to remain with 66 equal to n times n minus 1 over 2. 2 factorial is equal to 2. Then we will have n squared minus n equal to 132. 132 times 66, this is 132. And this will be the same as n squared minus n minus 132 equal 0. And we get a quadratic equation. This quadratic equation, I hope you remember how to solve this kind of quadratic equation. I'm going to write the solution here. So we have a equal to 1 and b equal to minus 1 and c equal to minus 132. Yes. So n1, the first solution will be equal to minus b times plus square root of b squared minus 4ac over 2a. And the second solution n2 will be equal to minus b minus square root of b squared minus 4ac over 2a. Yeah. So you see that n1, this implies that n1 will be equal to minus b. B is equal to minus 1, so minus b is equal to 1 plus square root of b squared. B squared is minus 1 squared, this is 1, and minus 4 times 1 times minus, then plus 4 times 132 and over 2a. A is equal to 1, so then over 2. And the other root will be n2 equal to 1 minus square root of that number, 1 plus 4 times 132 and over 2. Yes, so I'm not going to compute this one, but you can compute this square root, and the final answers will be, the final values will be n1 will be equal to 12 and n2 will be equal to minus 11. And this minus 11 has to be rejected. Why do I reject this one? Because n represents the number of students, so then the number of students cannot be negative. So this one is rejected, and the final answer would have been n equal to 12. In the class, there were 12 students, and the number of handshakes were 66. So that was it. The number of students in that class was 12 students. Now let's move to the next question. Next question is question number 11. It says each student in a class gives each other a shake hand. Sorry, excuse me. If there are 66 handshakes done in general, how many students are in the class? So this question, is it about the permutation or it's about the combination? For those who have not yet watched my videos about permutation and combinations, I saw that many people didn't watch those videos, but those videos are important. Please, I recommend to go and watch those videos. I'm going to pin those two links in the comment sections for you to watch if you are interested, of course. But for this question, we have shaking. The action is shaking hands. So if I am John and you are James, we are shaking hands. Hi John and hi James. It doesn't matter by starting saying that John shakes hands with James, or James shake hands with John. It's just one shake hands. There will be no two shake hands. So it's just one shake hands between James and John. Yeah, so since the order here, it doesn't matter, we have combination, because the order here doesn't matter. For one action, it's just one action, even if two people are involved in the action, but the order doesn't matter, so then we have combination. So all what we have in this equation is that we know that number of handshakes is 66. We have number of handshakes is 66 handshakes. So this number of handshakes, it will be a combination of number of students. I call it n, then 2, because two people have to shake hands. And I hope you remember this formula when we are computing the combination nr into r. So this is equal to n factorial over n minus r factorial times 2r. Not 2, times the r. I say 2 because I have 2 there. So times the r factorial. This is the general formula for combination calculations. Yeah. So similarly, we will have 66, which will be equal to n factorial, n being the number of students, then over n minus 2 factorial times 2 factorial. Yes, like this. So this will be the same as 66 equal to n factorial is the same as n times n minus 1 and times n minus 2 factorial, and over, I'm expanding it so that I will be able to simplify, then over n minus 2 factorial times 2 factorial, and I can simplify this n minus 2 factorial and n minus 2 factorial to remain with 66 equal to n times n minus 1 over 2. 2 factorial is equal to 2. Then we will have n squared minus n equal to 132. 132 times 66, this is 132. And this will be the same as n squared minus n minus 132 equal 0. And we get a quadratic equation. This quadratic equation, I hope you remember how to solve this kind of quadratic equation. I'm going to write the solution here. So we have a equal to 1 and b equal to minus 1 and c equal to minus 132. Yes. So n1, the first solution will be equal to minus b time plus square root of b squared minus 4ac over 2a. And the second solution n2 will be equal to minus b minus square root of b squared minus 4ac over 2a. Yeah. So you see that n1, this implies that n1 will be equal to minus b. B is equal to minus 1, so minus b is equal to 1 plus square root of b squared. B squared is minus 1 squared, this is 1, and minus 4 times 1 times minus, then plus 4 times 132 and over 2a. A is equal to 1, so then over 2. And the other root will be n2 equal to 1 minus square root of that number, 1 plus 4 times 132 and over 2. Yes, so I'm not going to compute this one, but you can compute this square root, and the final answers will be, the final values will be n1 will be equal to 12 and n2 will be equal to minus 11. And this minus 11 has to be rejected. Why do I reject this one? Because n represents the number of students, so then the number of students cannot be negative. So this one is rejected, and the final answer would have been n equal to 12. In the class, there were 12 students, and the number of handshakes were 66. So that was it. The number of students in that class was 12 students. Yes, next question. The next question is question number 12. Evaluate this integral. Yeah, so this is an integration. So let's go ahead and evaluate it. We have to evaluate this integration of square root of 1 minus sine x and dx. We evaluate this integral. What do we have to do? What we have to do is to try to remove this root. We are going to remove the root, and how are we going to remove root? We have to transform this into a square. We have to transform this into a square first. Let's transform this sin into a function of sine of x over 2. I think you remember this relationship. Sine of x equal to sine of x over 2 and times cosine of x over 2. I think you remember it. And the other relationship that we have to know is that 1 is equal to sine squared of x over 2 plus sine squared of x over 2. This also holds. Then we replace this into our integral. Then our integral, let's say that it's I. So I will be equal to integration of square root of sine squared of x over 2 plus cosine squared of x over 2 minus 2 times sine of x over 2 times cosine of x over 2, and of course dx. So what do you see here? This is a quadratic rotation that is known. So this is equal to integration of square root of, this is the same as sine squared of x over 2 minus 2 times sine of x over 2 times cosine of x over 2 plus cosine squared of x over 2. Yes. So if I say that, let me say, if I say that this sine squared of x is equal to x squared. Let me use a. Let me use a. Let's say that this is a squared and this is b squared, and then this will be equal to a times b. So we have the relation b, not b. We have the relation a squared minus 2ab and plus b squared, and we all know that is equal to a plus a minus, not plus, a minus b and squared. So we are going to rewrite to this relationship. So rewriting to this relationship, this will be equal to integration of square root of sine of x over 2 minus cosine of x over 2. Let me use the same x. Yes, x over 2 and squared like this. Yeah, dx. And you can see that this square and this root is going to be simplified, and this will be equal to integration of sine x over 2 or minus cosine of x over 2 and dx. So this will be equal to what? There is a dx missing here. Let me write it there. Yes, and then this will be equal to integration of sine x over 2 dx and minus integration of, write it where, integration of cosine of x over 2 dx. Yes, so this is equal to x over 2, then there is 1 over x missing, though this is cosine of x over 2 over 1 over 2, because x over 2, if we differentiate it, it will be 1 over 2, so 1 over 2 is missing. That's why I divide it. So, and cosine of x over 2, when we integrate it, it will be minus sine of x. This is minus, then minus sine of x over 2 over 1 over 2 and dx. No, not dx. And plus a constant. Dx is gone. Dx is gone. Then we add a constant. So do you know why we add a constant? If you know why we add a constant here, write it in the comment section. If you don't know it, write that you don't know it, then I will know that I will have to explain it next time. Yes, so this will be equal to 1 over 2, 1 over 2. This is equal to 2 times cosine of x, or not cosine. We can start with cosine or sine. You can start whatever you want. Then cosine of x over 2 plus sine of x over 2 and plus a constant. And that was it. That was our integration I. Yeah, I equal this one. So this was the answer. Wasn't it easy? Yeah. If you have any question, write it in the comment section. But otherwise, that was the answer. That's it. Let's move to the next question. The next question is question number 13. Determine whether the integration from minus infinity to 0 of this function x times e power x dx is convergent or divergent. When is an integral is convergent and when is it divergent? It is convergence if it is equal to a real value, and it is not convergent. Is it real value? If it is not infinity, if its value is not infinity, but if the value is infinity, then it is said to be divergent. Yeah. So what we have to do in this equation is to compute this integral and see if we will get a value which is different from either minus infinity or plus infinity. If we get that value, it will be convergent. if we get minus infinity or plus infinity, then this integral will be divergent. So let's do so. Let's compute it, let's calculate it and see what we are going to get. What are we going to get? We have integration from minus infinity to 0 of x times e power x dx. This is what we have to do. Normally this integration is equal to limit when a given value, let me say t, tend to minus infinity of this integration. I replace t minus infinity by t here, then 0, then e power x times e power x dx. Yeah, so what am I going to do? We are going to, let's suppose that we have this integration from t to 0 of x e power x dx. Let's first compute this. To do this kind of integration, we compute this integration by parts. Do you remember how to compute integration by parts? By parts. When we are computing integration by parts, we rely on this relationship. Integration of u dv should be equal to u times v minus integration of v times du. This is a relation that we are going to rely on it. So let's suppose that let u equal to x. So if u is equal to x, this implies that du is equal to dx. Yeah. And let v in this case, dv in this case is equal to e power x. Here we took x and then e power x to be dv. So this implies that v will be integration of e power x, so it is equal to e power x. Yeah. So then our integration I will be equal to u times v. U is x times v. V is equal to e power x, then times e power x, and minus integration of v. V is equal to e power x, and then du. Du is equal to dx, like this. So this is equal to x e power x and minus e power x. Yeah. Yes, and plus a constant, but the constant I don't need it because I'm going to evaluate this integration. We are integrating from t, and so let me insert our borders. We are this one we evaluated from t to 0, and this is also from 0 to from t to 0, not from 0. This one is from t also to 0. So this is written as like this, from t to 0, like this. All right. And you can see that this is equal to integration, so this is equal to when I will replace by x by 0, we will get 0 here times e power 0. E power 0 is 1. E power, so we will get minus 1, then minus what? If we replace by t, we will have t times e power t and minus e power t, like this. So this is equal to minus 1, and this can be written as minus e power t times t minus t minus 1, like this. That's our e. This is our e. Then finally our integration from minus infinity to to 0 of our function our function x e power x dx will be equal to what? It will be equal to limit when t tend to minus infinity of minus 1 times minus 1 minus e power t times t minus 1. So this is equal to what? We all know that when t tend to minus infinity, this e power t tend to 0. When we know that when t tend to let me write it this way, tend to minus infinity, then e power t tend to 0. It tend to 0, and t minus 1 tend to minus infinity. But this e power t, it goes fast to 0 than t minus 1, than the way t minus 1 goes to minus infinity. So then, since this one is very fast, this one will tend to 0 when t tend to minus infinity. And the final answer will be that all our limit, this integration from minus infinity to 0 of x e power x dx will be equal to this minus 1 here, equal to minus 1. Yeah. If you don't use these knowings, you can also use the hospital rule to remove the determination, but no need, since this e power t tend to 0 faster than t minus 1 tend to minus infinity, then all this product will tend to 0 and we remain with this minus 1. So therefore, since we get the value minus 1, which is not infinity, our integral, this integral converge. It converge, this converge, it converges to minus 1. So this is a convergent integral. Thank you. That was it. If you have any question, write the question in the comment section. Otherwise, that's it. The next question is question number 14. It says, find the mean value with respect to x of the function 5x squared minus 4x for 1 less than or equal to x less than or equal to 3. This is finding the mean value of a function. We have to use the mean value law. Do you remember the mean value law? The mean value law. That's what we have to apply here. The mean value law. When we have x, which belong to a given interval a b, and we have a function of x, and we are asked to compute the mean value. Let me say f bar of this function is equal to 1 over b minus a times integration from a to b of our function f of x dx. This is the mean value law that we have to apply to this function. And in our case, the function f of x is equal to 5x squared minus 4x. This is our function. So the mean value average f is equal to 1 over b minus a. 1 over b minus a. And what is b minus a? 1 over b is 3 minus 1, because we have been given that 1 is less than or equal to x less than or equal to 3. So a is equal to 1 and b is equal to 3. So 1 over 3 minus 1, integration from 1 up to 3 of our function f of x of 5x squared minus 4x and dx. Yes, so this is equal to 1 over 2, and this integration will be equal to, this is 5 over 3 x power 3 minus 4 over 2, this is a 2x squared, yes, like this, yes, and then we integrate from 1 to 3, yes, we integrate from 1 to 3, and so this is equal to 1 over 2 and times 5 over 3 times 3 power 3, this is 27, and this is times and minus 2 times 9, and then minus we are going to replace x by 1, then 5 over 3 the minus 2, like this, yes. So this is equal to 1 over 2 times, this is, if I simplify here, and 3, this is 9, this is 45 minus 18, and minus, and 2, 6 minus 6, and plus, this is minus 1 over 6, yes, minus 1 over 6, minus, and minus, then plus 1 over 6, like this, yes. And you can compute this. If you you compute this, you will have something like you will remain with the final answer will be equal to 82 over 6, and this is equal to 41 over 3. Yeah, so that was the answer. Yeah, that was the mean value. So keep in mind how to compute the mean value. Keep in your mind this mean value law. Thank you. And the next question, which is the last question for this session, is question number 15. It says, if the focus of a standard ellipse is at 1, 0, and the corresponding directrix has the equation x equal to 4, find its equation. So we are going to find equation of an ellipse. We are going to find equation of an ellipse, and this is a standard ellipse. If it is a standard ellipse, its general form should be x squared over a squared plus y squared over b squared equal to 1, because we have been told that it is a standard ellipse. If it is a standard ellipse, it should have this form. So what we have to find is a squared equal to what, and b squared equal to what. So what is missing? What we have been given is the force. The force is equal to this point 1, 0, and we have also given the directrix. Directrix is a line of equation x equal to 4. And then what do we have to do? Okay, or what we have to know for an ellipse, the force has coordinates c. It's plus or minus c, of course, plus or minus c. But then let's say take c0, then or I can write plus or minus c, because we have two forces. Yes, so we have been given one force, then c, in our case we have c equal to 1, yes, and again the directrix for a standard ellipse, it has equation. For ellipse, it has equation x equal to, it's plus or minus a over e. E is eccentricity, and the eccentricity, E is eccentricity, eccentricity, not x like that. Eccentricity, and the eccentricity E is equal to c over a. Yeah, so that's what we have for a standard ellipse, and we have only this is c, and we have also this was given to be equal to 4. So and also the other relationship that you have to know is that c squared is always equal to a squared minus b squared for an ellipse, of course. We are going to use this relationship also. So we have c equal to 1, and we have a over e equal to 4, and we have e equal to c over a. Yeah. So from here, what do we get? From here, you can see that we can replace this in a over e equal to 4. We can replace this e by its value here, c over a. Then we will get, what do we get? We get a over c over a equals 4. And this is the same as, this is a squared over c equal to 4. And we have been given that c is equal to 1. Since c is equal to 1, this is c is equal to 1, this is c is equal to 1. So then what do we get? We get that a squared is equal to 4. See? Easy. A squared is equal to 4. And we come back to this relationship here. If we come back to that relationship, given that c squared is equal to a squared minus b squared, you can see that b squared will be equal to a squared minus c squared. And then we replace a by its value and c by a squared by its value and c squared by its value. So we get b squared equal to a squared is equal to 4 and c is equal to 1. So c squared is equal to 1. So we get b squared equal to 3. And since we have already a and b, a squared and b squared, a b squared equal to 3 and a squared equal to 4, so our ellipse becomes x squared over a squared, which is equal to 4, and plus y squared over b squared is equal to 3, then equal to 1. So that was it. That was our ellipse, the equation that we was asked. So that was it, and that's it for today. I hope you like this video and you have understood something. If you have any question, don't hesitate to write the question in the comment section. And please, if you like the video, click like and share the video to your network. Thank you for watching, and I hope to see you next time. Bye.